Hello again. Let's continue with the demonstration of the proofs required for CCEA A2 Master exam. Today I will be presenting the proof of projectile formulas, which are required for Section A Mechanics of the A2 Unit 2 Applied Maths paper. Let's get started. To prove the type of flight formula, we will consider the vertical motions from the launch to the landing, with the upward direction being positive. We let the initial velocity to be u and the vertical component as uv is launched at an angle theta above the horizontal, and the time of flight is denoted as capital T, and therefore we're using s equal to ut plus half at squared with the following values. U equal to uv, which is equal to u sine theta, the initial vertical velocity. S equal to 0, because the object lands at the same vertical position as the launch. T equal to capital T, which is the time of flight. A equal to minus g, the acceleration due to gravity, which is negative since it's pointing downward. We can substitute those values into the equation, so that we have 0 equal to u sine theta times t plus half minus g times t squared. We simplify and factoring out t, so that u sine theta minus half gt times t equal to 0. And this equation implies two possible answers, which the first one will be t equal to 0, which is when it's launching, or u sine theta minus half gt equal to 0. We can solve for t in the second case, so that u sine theta equal to half gt, which gives t equal to 2u sine theta over g, which is the time when it's landing. Therefore, the time of flight is given by t equal to 2u sine theta over g. That's the end of the proof of time of flight. We will prove the formula for the greatest height by considering the vertical motion from the launch point to the highest point reached, considering upward as positive direction. We let the initial velocity be u and its vertical component as uv is launched at an angle theta above the horizontal. Therefore, using v squared equal to u squared plus 2as with the following values. U equal to uv equal to u sine theta, which is the initial vertical velocity. V equal to 0. The vertical velocity becomes 0 when the object reaches its greatest height. S equal to h marks the object which is its greatest height. A equal to minus g, acceleration due to gravity, which is negative once it's pointing downward. We can substitute those values into the equation, which gives 0 equal to u sine theta squared plus 2 minus g times h mass. And then we have 2gh mass equal to u squared times sine theta squared. Solving for h max will be equal to u squared times sine theta squared over 2g. Therefore, the greatest height is given by h max equal to u squared times sine theta squared over 2g. This is the end of the proof of the greatest height. Lastly, we will prove the equation of the flight path. Consider the motion of a particle from O to the point P, x, y. We let the initial velocity be u and its horizontal and vertical components are uh and uv respectively. The particle is launched at an angle theta above the horizontal and the time taken is t. Therefore, we can use the following equations. For vertical motions, using s equal to ut plus half at squared with the following values. U equal to uv equal to u sine theta, which is the initial vertical velocity. S equal to y, that is the object lands at the same vertical position at the launch. T equal to the time of the flight. A equal to minus g, which is the acceleration due to gravity, which is negative since the pointing downward. Substituting those values into the equation, we get y equal to u sine theta times t plus half times minus g t squared. We call this equation 1. For horizontal motions, using distance equal to velocity times time, we have x equal to u cos theta times t. We rearrange that, then we have t equal to x over u cos theta. We call this equation 2. Substituting equation 1 into equation 2, we get y equal to u sine theta times x over u cos theta plus half minus g times x over u cos theta squared. Simplifying further, we have y equal to x tan theta minus x squared over 2u squared times cos theta squared. Since 1 over cos theta squared equal to sec theta squared, which is also equal to 1 plus tan theta squared, then the above equation can also be written as y equal to x tan theta minus g x squared sec squared theta over 2u squared, or y equal to x tan theta minus g x squared times 1 plus tan theta squared over 2u squared. Therefore, the equation of the path of flight is y equal to x tan theta minus x squared over 2u squared times cos theta squared. That is the end of the proof of the equation of the path. That's all for today. I have demonstrated the proofs of the projectile formula, which are all necessary for Section A Mechanics of the A2 Unit 2 Applied Maths paper. If you'd like a copy of the proof mentioned above, please send me a private message. This concludes the series of proof required for the CCEA A2 Mathematics exam. Thank you for watching. If you enjoyed my video, please like, share, and subscribe to my channel. Thank you, and best of luck with your exams. Goodbye.